Hi, I'm SmartScience. Today we're going to be talking about atoms. Let's get started and let's learn together. Atoms are the basic units of matter, the defining structure of elements. The term atom comes from the Greek word indivisible because it was once thought that atoms were smallest things in the universe and could not be divided. We now know that atoms are made up of three particles, protons, neutrons, and electrons, which are composed of even smaller particles such as quarks. Atoms were created after the Big Bang 3.7 years ago. As the hot, dense, new universe cooled, conditions became suitable for quarks, and electrons to form quarks came together to form protons and neutrons. And these particles combined a nuclei. This all took place within the first few minutes of the universe's existence, according to CERN. It took 380,000 years for the universe to cool down enough to slow down the electrons so that nuclei could capture them to form the first atoms. The earliest atoms were primarily hydrogen and helium, which are still the most abundant elements in every universe. Gravity eventually caused the clouds of gas to coalesce and form stars, and heavier atoms were created within the stars and sent throughout the universe. When the star exploded, protons and neutrons are heavier than electrons and reside in the nucleus at the center of the atom. Electrons are extremely lightweight and exist in a cloud orbiting the nucleus. The electron cloud has a radius 10,000 times greater than the nucleus. Protons and neutrons have approximately the same mass. However, one proton weighs more than 1,800 electrons. Atoms always have an equal number of protons and electrons, and the number of protons and neutrons is usually the same as well. Adding a proton to an atom makes a new element, while adding a neutron makes an isotype or heavier version of an atom. This is all the notes I took about nucleus. The nucleus was discovered in 1911 by Ernest Rutherford, and now a physicist from New Zealand, who in 1920 proposed the name proton for the positively charged particles of the atom. Rutherford has also theorized that there was also a neutral particle within the nucleus, which James Chadwick, a British physicist and student of Rutherford, was able to confirm in 1932. Virtually all the mass of the atom resides in the nucleus, and protons and neutrons that make up the nucleus are approximately the same mass and have the same angular momentum, according to Lawrence Berkeley National Laboratory. The nucleus is held together by the strong force, one of the four basic forces in nature. This force between the protons and neutrons overcomes the repulsive electrical force that would, according to the rules of electricity, push the protons apart. Otherwise, some automatic nuclei are unstable because the binding force varies for the different atoms based on the size of nucleus. These atoms will then decay to other elements. This is all the notes I took about protons. Protons are positively charged particles found within atomic nuclei. Rutherford discovered them in experiments with cathode ray tubes conducted between 1911 and 1919. Protons are slightly smaller in mass than neutrons, with a relative mass of 0 and 9,986 10,000ths, as compared to the mass of the neutron being 1, or about 1.673 x 10 through 27 kilograms. The number of protons in an atom defines what element it is. For example, carbon atoms have 6 protons, hydrogen atoms have 1, and oxygen atoms have 8. The number of protons in an atom is referred as the atomic number of that element. The number of protons in an atom also determines the chemical behavior of the element. The periodic table of elements arranges the elements in order of increasing atomic number. 3 quarks make up each proton, 2 up quarks, each 2/3 positive charge, and 1 down quark with a 1/3 negative charge. And they are held together by subatomic particles called gluons, which are also massless. These are all the notes I took about electrons. Electrons are tiny compared to protons, and neutrons over 1,800 times smaller than either a proton or a neutron. Electrons have a relative mass of 0.005439 as compared with the mass of a neutron being 1, or about 9.109 x 10 through 31 kilograms. J.J. Thomson, a British physicist, discovered the electron in 1897, originally known as corpuscles. Electrons have a negative charge and are electrically attracted to the positively charged protons. Electrons surround the atomic nucleus in pathways called orbitals, and idea was put forth by Erwin Schrödinger, an Australian physicist in the 1920s. Today, this model is known as the quantum model or the electron cloud model. The inner orbitals surrounding the atom are spherical, but the outer orbitals are much more complicated. An atom's electron configuration is the orbital description of the locations of the electrons in a special atom. Using electron configuration, the principles of physics can predict an atom's properties such as stability, boiling point, and conductivity. Typically, the outermost electron shells matter in chemistry. The inner electron shell notation is often truncated by replacing the longhand orbital description with the symbol for noble. Gas in brackets. This method of notation vastly simplifies the description for large molecules. For example, the electron configuration by beryllium L is B1s22s2, be written as He2s2. He is equivalent to the electron orbitals of a helium atom. The letters S, P, D, and F designate the shape of orbitals, and the superscript gives the number of electrons that an orbital uranium. As another example that has electron configuration of 1s, 22s, 22s, p63s, 23p, 64s, 23D, 104P, 65S, 24D, 105P, 66S, 24E, 145D, 106P, 67S, 25F4, which can be simplified to 7S, 25F4. These are all the notes I took about neutrons. The neutron is used as a comparison to find the relative mass of protons and electrons. So it has a relative mass of 1 and has a physical mass of 1.6749 10,000 times 10 through 27 kilograms. A neutron's existence was theorized by Rutherford in 1920 and discovered by Chadwick in 1932. Neutrons were found during experiments when atoms were shot at a thin sheet of beryllium. Subatomic particles with no charge release the neutron. Neutrons are uncharged particles found within all atomic nuclei, except for hydrogen-1. A neutron's mass is larger than that of a proton. Like protons, neutrons are also made of quarks. One up quark with a positive 2/3 charge, and 2 down quarks with a negative 1/3 charge. This is all the notes I took about isotypes. The number of neutrons in a nucleus determines the isotope of the element. For example, hydrogen has 3 known isotopes: protium, deuterium, and tritium. Protium symbolizes 1H, is just ordinary hydrogen. It has 1 proton and 1 electron, and no neutrons. Deuterium D, or 2H, has 1 proton, 1 electron, and 1 neutron. Tritium T, or 3H, has no proton, 1 electron, and 2 neutrons. Thank you for watching Smart Science. I hope you enjoyed that video. That video took me about 2 hours to take all that notes, and even though it was like a 12-minute long video. And leave a like, comment down below if you learned anything. Be aware for the quiz when I'm done with this learning about all the other stuff in physical science. Thank you for watching. Subscribe.